welcome to all of us. May I now request Dr. F.C. Kohli to give his inaugural address.
Can you switch off that light? Good morning to all of you. Well, the subjects that you are going to discuss over the next 2 days are very important for the people who are working in information technology. You're talking about the social networking, that is the confluence of social sciences and the technology. You're going to talk about innovation, and you're going to talk about the knowledge. What I'm going to do is, I'm going to do about 5-minute commercial on myself, telling you what I have been doing all these years, and then talk about something about the level of computerization and knowledge management in the country. I will start with something for those who feel that what they have learned in the college will sustain them throughout their life. Some years ago, the MIT Department of Electrical Engineering was celebrating 100 years of existence, and they had set up a committee to look at future of the engineering. Why I'm telling you this, the same thing is going to happen with the knowledge engineering. The committee came to a conclusion that in future the engineers would have 40 years of working life. They will have 4 distinct careers in those 40 years. And when I talk about distinct, it doesn't mean the promotion. And 2 of those areas would be for which the technology is not discovered when the person graduates. It happened to me. When I graduated, there was no digital technology. The transistor was discovered or invented that very year of my graduation. And yet, I spent about somewhere almost 45 years in this technology, starting from 64 onwards. First 18 years I was with the Tata Electric companies, generating and transmitting and distributing power to Bombay-Pune region. We started using computers from 64 onwards for Tata Electric Company. By the time I left Tata Electric Company in 69 to giant TCS, we had computerized almost all Tata Electric Companies' processes, controls, load scheduling, and others. One of the reasons I say that the city of Bombay never gets it shut down is related to introduction of information technology in Tata Electric system in 60s. I will talk about TCS a little while because it has a lot of instructive things how a company is set up when the technology is totally new, and it was new for this country. The 2 things were there that when we started TCS, we knew. One, the technology was new. The technology was moving very rapidly, with current technology becoming obsolete within the next few years. Therefore, anybody entering the field would need continuous education in technology and working closely with the US and West, where the technology is. The second factor that was uppermost in our mind was the capability and the quality of the mind of the Indian student. We recognized this way back, and in January 1975, as a president of Computer Society of India at its annual convention in Ahmedabad, I said, lastly, I want to say that many years ago there was an industrial revolution. We missed it due to reasons on which we had no control. Today there's a new revolution, and that is a revolution in information technology, which requires neither mechanical bias or mechanical temperament. Primarily, it requires the capability to think clearly. This we have in abundance. We have an opportunity to participate in this revolution on equal basis. We have opportunity even to assume the leadership. So those were the two things. One was the technology and the other were the people that started TCS. But in the initial years, there were many hurdles. There was a mindset in the government, politicians, bureaucrats, and the union that computer cause unemployment and also reduce potential employment. Therefore, India should not go for computerization. Apart from that, there was a lack of availability of hardware. It took us, in those days, almost 3 years to get a computer, to get an import license for the computer. And by the time import license was given to you, the computer was already obsolete. We kept on reviewing our technology knowledge base and also continuously updated ourselves so that we could go for the most complex assignments, and we could also learn more about the latest technology. Earlier years we did some significant assignments using hardware which was totally inadequate, like in 1970 we computerized the telephone directory for the Bombay telephones. It was the 4th or 5th directory in the world which was computerized. Earlier in Tata Electric Company in 1968, we installed a digital computer to control the power flows on the system. Again, we were about 4th utility in the world to go for digital controls. UK, France, Germany and Japan were still on analogs. Our first assignment abroad came towards the end of 1974 from Burroughs. Burroughs has come out with a significantly new design machine which was totally developed in a higher language like ALGOL, and they needed the healthcare system. In 1974, we did that entire job out of India. People today talk about outsourcing. Of course, we didn't have the Burroughs machine, so all the testing and everything had to be done on site. But that established the credibility for TCS and for India that we could do it. Throughout these years, and even today, we have felt that we have to keep on training our people, we have to provide continuing education for our people, because as I said, the technology is changing rapidly, it becomes obsolete, and you have to renew your knowledge and the people. I want to submit here that there's hardly any computerization in this country. I will go through it a little later on. It might surprise you because some people have been saying that India is a superpower in computers. India's software revenue, for which we are known all over the world, last year was $40 billion. About $32 billion came from exports and $8 billion from domestic. Out of that $8 billion that is domestic, perhaps half of Microsoft, Oracle and all that, which we imported and resold, it also counts for your Indian domestic scene. Now, the total worldwide software is $2,000 billion. So 40 billion is about 2%. And outsourcing is about $300 billion, and we have $30 billion of export, so we account for about 10% of outsourcing. Both these figures cannot make you a superpower, but it gives us an opportunity to keep on climbing up. India has no hardware industry worth talking about. We have done about 9 billion, and our input of personal computers is about 6 million. And but what we have learned is tremendous in all these years. We have worked on a spectrum of software, engineering design, embedded system, financial system, decision support systems, and we have provided reliable and quality service. We have created over 1.5 million jobs for professional and many more at the sport level. Before I talk to you about computerization in India, let me give you some figures for China, because China's software, domestic software, last year was $55 billion as against our $9 billion. China's hardware industry is over $200 billion, and their input of personal computers is used within the country is 20 million PCs a year. Where Chinese have scored over us, they have used computers for their own development. They developed extensive and complex software in Mandarin and Cantonese for use in industry, manufacturing, administration, education, healthcare, agriculture, project management. And this has contributed to China's rapid growth since 1990. And I want to emphasize this, because I'm going to talk about it, what we need to do. Now, IT is both software and hardware, and it has improved employment and job opportunities. It has made large and small enterprises, retail services, highly efficient and productive. Coming to our own country, I would submit the level of computerization is extremely low. India has hardly any hardware industry. Its software is mainly export-oriented and written largely for English-based applications. There are 900 million people in this country who don't speak English, and they need computers. We need computers extensively in government, defense, manufacturing, finance, agriculture, transportation, education, and retail services. To achieve the desired level, we will need affordable hardware and also software in Indian languages. That I will tell you what we have done in the last 5-6 years. And we think that if India computerizes in Indian languages, we would need almost 20 million PCs a year. We'll need digital components for these computers and for digital television sets, communications, mobile phones, industrial controls, video and sound equipment, automobiles and other industries, including defense. In the manufacture of digital components, there are 3 steps. The first is the design engineering. This is carried out by using advanced software on computers and requires microelectronic engineers. The second is what we call building functionality on the silicon, that is the embedded software. And more software is getting embedded below the operating system level, and in future perhaps the operating system also will be embedded. This can be done by microelectronic engineers, and software engineers can be trained to provide this. The last one is fabrication. That is done in silicon foundries. What we have suggested, and we are working on with the government, that fabrication we will outsource, and the first 2 steps we will do in this country, considering that the value added in first 2 steps is 80%, and a silicon foundry, even a small silicon foundry, costs $3 to $4 billion. So perhaps we can first learn to build components and then undertake the manufacture, but there's surplus capacity available for fabrication all over the world. When we started looking at this hardware scene, and what I've enunciated to you, we looked at how many microelectronic engineers the country was producing. That was 2002. And we found we were producing 200 microelectronic engineers, as against Israel and Ireland are producing about 1,000. And this number is grossly inadequate. TCS collaborated with IIT Mumbai to design a MTech program in microelectronics. IIT Mumbai is now producing 50 MTechs this year in microelectronics. The coursework, lectures, lab work, software, and the experiments developed at the IIT Bombay have been transferred to the Government of India, Ministry of Information Technology, and it has been suggested to them to select 100 engineering colleges to set up Department of Microelectronics with this material developed at IIT Bombay. They have so far selected 20, and but the net result this year is that we are producing about 1,000 microelectronic engineers, and we want to move on to 3,000 to 5,000, and that time we can become a design engineers to the world like the Israelis. We had also stated one of our objectives that we should be able to produce a fully configured computer with monitor for less than 10,000 rupees. And last year, HCL and Centis have placed such PCs in the market costing less than 10,000. Now coming to the software, what do we do about the Indian languages? We brought a lot of IITs, triple IITs, CDAC, NCST, and many other academias to develop software in Indian languages. Today we have open source operating system, middleware, like and search engines and databases, and few applications available in 10 Indian languages. Sun has given us their Office suite to translate in Indian language. TCS has given its financial package, EX. But we do not have sufficient applications in Indian language to bundle around this 10,000 rupees computers. Once we have that, this country will take off. Then another thing about this country which is a little different than out in the West is that India needs more employment. It has to use IT for creating more employment and also sustain the present employment. Now there are 2 or 3 experiments have been done in this country which I will share with you. In the city of Coimbatore, there are about 10,000 small engineering workshops employing anywhere 10 to 20 people. They are very innovative machinists, designers who produce components starting from electric motors, pumps, and also components for automobile industry. They have no access to computer-aided design, computer-aided manufacturing, material sciences. TCS has set up a large portal in the city where all this software is there on the machine, and these people are being trained to do their design work from their PC to on the portal. So already we are seeing the effect of it. It will increase their productivity. They will be able to design the components on computer rather than on the machines. And also their knowledge in material sciences is being augmented with the use of computers. Now, if we are able to increase their productivity, we have sustained the employment. Also, it will increase the employment, and they are still cost effective because a workshop with 20 doesn't need a chief engineer, it doesn't need a chief financial officer, and also the computers are helping their process of innovation. There's another thing that is being done at IIT Bombay with us. And that is, you're going to have shopping malls in this country. It's something middle class expects, and the middle class is growing in this country. There's nothing wrong with having that experience, shopping malls and all that. In the United States, the experience, perhaps you might have seen the book, Grisham's novel on the last year, which came out about 2.5 or 3 years back, where it shows that when Walmart moves into that town, all these small shops close down. Now, India has 10 to 20 million shops. If you take the other attendants in the shop, their family members, each shop supports about 10 people. So they support 100 million people in this country, almost 1/10 of the population. So what can we do that they remain in business? So we have studied their problem at IIT and some of others, and we have looked at their problems, how computers can help these shops to remain in business, and what they should be doing. We are designing some special tools for their inventory management, also for the cost management. And in what we are going to emphasize is the client relationship management. We are going to make these as a personalized stores, and which no shopping mall can beat. And just to give you an example, when I go to my corner store at 9 o'clock someday to pick up something, and if my dog is not with me, he asks about the health of my dog. No, this is a personalized storekeeping. And we want to emphasize this, that if you want something and and this fellow doesn't have it, the day he sends you an email, can I deliver you this? So I think there is a room for these people if we can make them efficient with use of computerized inventory management, computerized accounting, finance. They are borrowing everything, but in Indian languages. Now, we have been doing something on the education. I'll talk about two things. One is that education at the highest level, and also education or so-called literacy. India is not producing enough PhDs. And this study started somewhere with the government of India, somewhere year 2000. And we came to conclusion that you start the PhD program at the undergraduate level, not the graduate level. It's the amount of basic knowledge that you give those undergraduate will make all the difference. And we carried out a detailed gap analysis between some of the good engineering colleges and the IITs in governance, autonomy, finance, curriculum, faculty, library, labs. And IITs produce 3,000 world-class undergraduates, 2,000 go abroad, never come back. Another 500-600 go for management. So we are not left with enough body to pursue higher studies. But this country can't have 3,000, only 3,000. So when we said, let's look at it, all those colleges which cutoff point is 85 plus at 10+2 level, we found about 60 colleges. Now, if you have sweated for 12 years and you have achieved 85%, you are a good student. There's no question. You have the same caliber as the people who are going to IIT. It's only the next 4 years you give a very indifferent type of education, and they never develop. They do well in life because they are good people, they are good students. And so we started looking at it, how these gaps can be filled up. And Maharashtra government went along with us. We have taken 4 colleges out of the university system, made them standalone. And Pune Engineering College, which is the oldest engineering college, where the cutoff was 95. We would have brought their undergraduate school to the same level as IIT by middle next year. And this prototype can be given to all the 50 colleges. And then we will have 30 to 40,000 world-class undergraduates, not 3,000. Now coming to the last point that I have, want to share with you how we are using IT for cutting down or making people literate. This country has about 65% literates, and especially between adult literacies is not something to write home about. There are 150 million people who can't read and write in this country. The government is spending a lot of money on it, the state, center. But when we started looking at this problem about 6-7 years back, we say, why aren't we making progress more than 1 to 1.2% per annum? And we found there were constraints. You required 200 hours of instructions. You had to read, write, and do number work. And it required trained teachers. Now, if I am 25, I have to work for my living. How the hell I'm going to find 200 hours to spare to learn reading? And also, you have 500,000 villages. Where are you going to find 500,000 trained teachers? And which trained teacher would go and settle down in a village? So we started looking at it, the whole human learning process. How do we learn? How do we retain? How do we recognize? How do we recall? And we hit something which should have been obvious in the first, that we learn by images. Face is an image. If I see that face twice, the third time I'll be able to recall. And if I associate that with the name, then it sticks. And so we said, why do we have to teach people from alphabets? Why can't give them words? Recognition of the words. Let them learn alphabets backwards from the words. And then we set up ourselves an objective that after the people have been trained, they should be able to read newspaper in their own language. The first experiment we did in Andhra Pradesh with 25 women volunteers, and the size of vocabulary that we decided was 500 words. Some of you can look at it tomorrow morning's Times of India and count the words that you needed to read the news. It's around about 600 to 700. Difficult words you can bypass, so it doesn't. Within 600 to 700 words, vocabulary, you can read a newspaper. And we prepared animated lessons on the computer, and so that we don't need a trained teacher. So just we changed the keyboard to the local languages, and somebody had to press some of the keys. And the result was that after 8 weeks, 3 times a week, 1.5 hours, after 8 weeks, most of them started recognizing the headlines. After 10 weeks, they had achieved a reading speed of about 12 to 14 words. And they were ready to learn more. And so what we have done is that TCS has experimented in 6 Indian languages. We have experimented about 120,000 people, and the results same. And now this system has been handed over to Government of India, the Knowledge Commission and National Literacy Mission, who are adopting this system. And incidentally, the computers that we are using in this are hand-me-down. They are the earlier Pentium machines, which more than 200 million are available in the country. If the way we have proposed to the government, if they do it, there's enough computers of that vintage lying in the world, and we can clear the backlog of 150 million in 3 years. So that's some of the societal problems, and I think you are going to talk about the social networking. What I wanted to submit to you, computer has a very important role for a country like India to bring it up on the global scene. What we have going good for us is the quality of mind and quality of people. Let us use them. Thank you very much.
Thank you, Professor Kohli.